In this section, we'll be introducing polar coordinates. Polar coordinates are another way of graphing points, but we're going to be using the polar coordinate instead of the rectangular coordinate that we're used to with x and y. So in this case, we're going to have our point being r, which stands for the radius. And think of this as the radius of a circle. There's going to be a number, and this is going to be the number of circles that we're going to go out from to plot at, okay? This will make more sense here in a moment. So our angle is generally going to start off just like you normally have. This would be our angle theta. This is going to be along the polar axis. This center point where you are, think of it as your origin, we're going to call it the pole, since we're dealing with polar coordinates this time. This is going to be the length of your radius, and this point is going to be the point r comma theta. Okay, r for radius, theta for the angle. And our process for plotting is going to be to first start off with your angle. So think about how many degrees we're still going. One full rotation is 360. And then afterwards, you're going to plot your radius. If r is greater than 0, we're going to graph normally. If r is less than 0, so negative, we're going to graph opposite. And again, this will make more sense here in a moment. Now, r is the distance to the point P. So again, r is the radius, how many circles out you are from the center. Theta is the angle from the polar axis to a line segment, which is the distance of r. So we know that positive angles are measured counterclockwise just in our regular coordinate. If I was graphing an angle that's positive, I would go this way. If I was graphing a negative angle, then I would start off here and go this way. Okay, so we did this when we were graphing last semester, so we'll revisit that. So here's how it works to just plot these points. This is what the polar coordinate is going to look like. Okay, so again, I'm going to make another side note here that if r is greater than 0, the point is going to be normal. We're not going to do anything crazy to it. But if r is negative, then we are going to plot opposite of what we think. So starting off with number 1. So number 1, it's telling me 2, 135 degrees. And remember, we want to start off by graphing the 135 degrees. So 135 degrees, since it's positive, we're starting here at 0. We're going to move our angle. And we know that halfway here is 90. Then we add, that's 120, and then 135 would be along this line right here. Okay, so this is the angle, 135 degrees. And the 2 is referring to the circle number in here. So I have 1 circle, 2, 3. They get bigger and bigger all the way around. In this case, there are 6 circles total. Okay, the 2 is telling me that I'm going to go to that second circle, and that's where I'm going to graph it. So along the 135, I'm going to go 1, 2, right there. That is where I want the point to be. I'm going to call this point A so we remember what that is, and that's going to go right there. I'm going to clear my picture so that the other ones become easier, but that's just how we are graphing it, okay? The next one I'm going to call point B. Again, you start by graphing your theta, your angle theta. In this case, 3 pi over 2 is going to, again, positive means we're going to start here and go all the way around. 3 pi over 2 is right here. So technically, I have this whole angle all the way around. That's 3 pi over 2. Now, this is the new part where -3, if r is negative, remember looking at this note over here, That means that instead of going, so if it was positive, let me start off with that. I would say, oh, here's the 3 pi over 2. I'm going to go to the third circle. That would put me right there. But because the 3 is negative, I actually have to go along that same line, but in the opposite direction. So instead of being here, 3, I'm going to go back 1, 2, 3, and my point ends up being right there. That's the point B. So kind of a little bit tricky to explain on a video, but if it is negative, you are going to go backwards. Think of it like 180 degrees backwards, and that's how we're going to get that point. Okay, let's do a few more. I'm going to call this one C. In this case, my angle is negative, it's negative pi over 4. So again, starting here, I'm going to go clockwise is how I do a negative angle. So I'm going to come down just pi over 4, which puts me along this right here. Okay, and then same thing looking at the -1. The -1 tells me to follow along that line, but in the opposite direction. If it was positive, I would be right there, but because it's negative, I have to extend it the other way, and I actually end up being right here. And I made that line a little bit difficult to see, but that's the point C right there. Okay, so go the opposite direction. And one more, I'm going to call this the point D. So again, going clockwise for -4 pi over 3. So starting off here, going back around, this would be 3 pi over 3, right? Or just pi, and then one more will put me at 4 pi over 3. So all of this in this direction gives me -4 pi over 3. And then I want to make sure I'm in the fourth circle starting from the center. So 1, 2, 3, 4, I'm right there. And oops, I missed it. It's actually 1 over here along the fourth circle. And that's going to be the point D. Okay. So that's really the main point of graphing these. If you are going counterclockwise, that's because you have, so this way, that's because you have a positive angle, a positive theta. You're going to go down in this way if you have a negative angle, negative theta. And then the biggest thing is when we have these negative R values, we're going to, so if I'm supposed to be 1, 2, 3 here, but if it's negative, I have to go in the opposite direction, and that's where it would end up. Okay, so that's the biggest thing with graphing these. All right, so because there's different ways to get to the same point, we're going to talk about the multiple representations of a point in the polar coordinate system. So again, we're going to plot these points by using R for radius and theta for the angle. And before, we talked about how this plus 2 pi technically includes as many rotations around the circle, right? So like this point, I could come in once or add another 2 pi and go again, another 2 pi and go again. So that's what we're trying to do here with the different ways we can write this. So there's 3 different scenarios on how we can write the exact same point. So what I'm going to do first here is graph this point 3 pi over 3. So I'm going to sketch here my graph, and I have 1 R, so 1 circle around. This would have a radius of 2, and this would have a radius of 3. I know I need the 3 because that's my R value. And then pi over 3 would be right about here. So my point is right there. That would be the point 3 pi over 3. Okay, so how else can I write this exact same point, but thinking about other ways I can get there? So first scenario is if I had an R that's positive, a positive R, but then I also want to be in my second rotation, so between 2 pi and 4 pi. We know that 1 full rotation is 2 pi, so being between 2 pi and 4 pi means I'm doing 1 more rotation. So instead of just going 1 here, I'm starting there, but I'm going to extend it one more rotation. So think about how you write that, okay? My radius is staying the same. I'm still going to be at 3, so that part is going to be fine. But pi over 3, I'm going around the circle one more time. So how does that simplify? Well, again, the 3 is staying the same, but the 2 pi I can rewrite as 6 pi over 3. So really, we have 6 pi over 3 plus the pi over 3, which gives me 7 pi over 3. And again, this means that if I went, let me do that again. If I went one full rotation, starting here, one more, I'm adding another rotation to it. That's how I end up with that 7 pi over 3. Scenario B, I'm going to need to draw that circle again so we can see the last scenario a little bit better. Scenario B would be having a negative r this time. Negative means, remember, if you were originally supposed to be here, but negative direction, you go halfway the other way and then end up there. So how can I write that as a point so that I end up in the exact same place? This time I want to be just within one rotation. So I want to make sure that this is negative, the 3 is negative, and what I'm going to do is I'm going to add just half a rotation so that I end up in the same place. And I will visually show this here in a second. So instead I'm going negative 3, and then pi would be 3 pi over 3, which gives me 4 pi over 3 right here. So if I were to graph 4 pi over 3, I would start off here, and I would go all the way around to about there, okay? And this would be a positive 3, but because it's a negative, I go the opposite direction, 1, 2, 3, 1, 2, 3, and I end up exactly where I want it to be. So this would be another way to write the exact same point. All right, and one more scenario here. So scenario C would be for r to be positive still, but this time going a negative angle. So negative 2 pi to 0. So going in the opposite direction, starting here, going this way. So in this case, my r is still positive, okay? But this time I want to go the opposite direction. So I'm going to take my original pi over 3, and I'm going to subtract 2 pi from it. And 2 pi can also be represented as 6 over 3. So that gives me 3 comma negative 5 pi over 3. So again, we're not changing the radius this time. We're just changing our starting point. So we're starting here, but going counterclockwise, and then still being at that positive r. Okay, so really, these 3 angles or points all are in the exact same spot in my polar coordinate system. So let's go ahead and try this with these 2 examples. So I'm going to tell you whether the r is positive or negative, and then I'm going to tell you which way the angle should be. And we want to make sure that it matches this given point, 2 comma pi over 3. So if I want r to be negative, that means instead of being a positive 2, it's going to become a negative 2. And if I want it to be within one rotation, then I'm just going to add pi to it. So pi over 3 plus pi. And remember, this is the same as 3 pi over 3, which makes it a little bit easier to simplify. That gives me 4 pi over 3. And it's probably a good idea to double check. I would go ahead and plot the point. The given point in this case has 2 radius of 2, and then pi over 3 is right there. So I'm going to double check that this one that I just came up with would do the same thing. If I went pi over or 4 pi over 3, I would end up over here. But then because it's a negative 2, that means I go up in the opposite direction, and there it is. It does work. So definitely go back and check your answer if you want, just to double check. For number 2, I want r to be positive, so 2 is going to stay the same. But this time I'm going in the opposite direction, right? Negative angle going this way. So how can I start here, go in the opposite direction, and end up there, I'm going to mathematically just subtract the 2 pi. So pi over 3 is where I started, subtract the 2 pi, which again is the same as 6 pi over 3, to make sure I have a common denominator, and that gives me negative 5 pi over 3, which would make sense for that angle. So if you want to memorize the rules, what did we do for each one? Like over here, I subtract minus 2 pi when you're going in the opposite direction. When r is negative, you want to add pi, okay? Whatever you need to do, or if it just makes sense to do it, that works too. If you're going one more full rotation, you add 2 pi. So those are the 3 different scenarios we could have you do. You can either add one more rotation, you can use a negative r, or you can use a negative angle. So other than graphing these, we're going to ask you to go between polar and rectangular coordinates. Rectangular coordinates are the ones you already know. This is an example of a rectangular coordinate, x comma y. And now we're introducing r comma theta. So how do we go back and forth? What we have here is a right triangle in our normal rectangular coordinates. And I want to convert from polar to rectangular using these properties. So polar is all about the angle. Think of it as the trig functions, how we would use those. To find x in this, first I need to use theta here. And I can say that cosine of theta, so going back to SOHCAHTOA, if I'm doing cosine, this is my adjacent and this is my hypotenuse. So in terms of x and r, I would say that cosine is x over r. So if I want to find x, I would want to isolate the x by multiplying r to the other side. R times cosine of theta is what x equals. And this is actually in your golden ticket, so you don't need to memorize that, but this is where it comes from. To find y is sine, right? We know sine is our y value, and in this case, this is my opposite, and this is still my hypotenuse. So I would say that this is y over r. So again, to solve for y this time, solving for y, I would multiply the r over, so r times sine of theta is how I find my y value. Now, going from rectangular to polar is a little bit more complicated. So I know that I can find r, this case. If I'm given x and y, how would you solve for r? So just take it back to geometry. If you are given 2 sides and you're finding the missing side, you would use the Pythagorean theorem, right? So if this was my missing variable, I would say that x squared plus y squared, this squared plus this squared, would equal r squared, my longest side across my hypotenuse. And if I'm solving for r, that means I have to take the square root of both sides. So r is really the square root of x squared plus y squared. That's how I solve for r. And lastly, to find my theta, I have to use tangent. Okay, I need to know tangent of theta is, in this case, opposite over adjacent, so y over x. The way that it appears on the golden ticket, it says arc tangent, because we're not just finding the ratio of tangent, we're actually asking where on the unit circle, does tangent of whatever equal blah, blah, blah. Okay, so you really need to know your tangents. And we need to figure out, first of all, is tangent positive? Remember where tangent is positive. Tangent is positive in the first and third quadrant, okay? And then it really is helpful if you know your tangent values. So at any pi over 6 reference angle, our tangent's going to be square root of 3 over 3. At any pi over 4, we're going to have a tangent of 1. And at any pi over 3, we're going to have a tangent of square root of 3. So those are good things to memorize. And again, this appears on your golden ticket as arc tangent because you're not setting up the ratio, but you're going backwards and saying, okay, where on the unit circle does tangent equal this? So let's just go ahead and start practicing these. First, we're going to find the rectangular coordinates of the points with the following polar coordinates. So I want to turn these into rectangular coordinates. So my final answer should be in terms of x comma y. All right, so to find our x value, again, this is all in your golden ticket. X is going to be r times cosine of theta, and y is going to be r times sine of theta. As long as you remember that the first number here is your r, and this is your theta, then you just have to put it into the formula, okay? So r is 2, and cosine at 3 pi over 2, here's where you need to know your unit circle. So think about, what is cosine at 3 pi over 2? That's 0. And 2 times 0 is 0. So my x value for this point is 0. Now we're going to do the same thing for the y. So r is still 2. And now I'm thinking about what sine at 3 pi over 2 is. Okay, so 2 times sine at 3 pi over 2 is a negative 1, which means my y value in this case is a negative 2. So the point is at 0, negative 2. We're going to do it again. And this time the point is negative 8 and then pi over 3. Again, this is your r, this is your theta. So looking for x, we're doing r times cosine of theta. R is negative 8 times cosine of pi over 3. And that equals negative 8 times cosine of pi over 3 is 1/2, which means x is negative 4. So my point, x is negative 4. And we're going to do the same thing for y. That's r times sine of theta. R is negative 8. Sine of pi over 3 is going to equal square root of 3 over 2. And then just simplify that. We're simplifying this as these cancel and this becomes a 4. So I can write it as negative 4 square root of 3. And that would be your y value. Okay, which makes that your point in rectangular coordinates. And that's it. So this is the easier one. Now we are going to go backwards and find the polar coordinates given the rectangular coordinates. So I want to show you really quick where on your golden ticket you're going to find these. So it's on this side, the CRT formula sheet, and you're looking on the right hand side for complex numbers. You see right here it says converting rectangular coordinates to polar coordinates and then polar to rectangular. So the bottom part is what we just did. And now we're going to be using the rectangular to polar. So we're going to be solving for r by doing the square root of x squared plus y squared. And then that's where the arc tangent comes in. Remember, you're asking where in the unit circle does tangent equal this. So let's start off with a few reminders. And remember that r is your radius. So r is always going to be positive. Okay. And then it is helpful to maybe plot the point first, just to see which quadrant is in. So to know quadrant for theta. So in this case, if I'm plotting the point negative 1 square root of 3, okay, negative 1 is going to be left, and then a positive square root of 3, like somewhere here, right? So this is quadrant 2. This is important so we remember, all right, is tangent positive or negative, and then go from there. Let me start off by finding r, and again, this was in the golden ticket. I just showed you where r is the square root of x squared plus y squared. This is in rectangular form, so this is a regular x and y, and we want to go backwards and write it in polar form. So let's just substitute into the formula. We're finding the square root of, your x value is negative 1 squared plus the y value is square root of 3, and we're going to square that. This simplifies to the square root of 4, so r is 2. Okay, I know that my final answer is going to be r comma theta, so I can go ahead and start writing that. 2 is my r. Now, to find your theta, first you're going to think about where tangent is y over x My y value is square root of 3. My x value is a negative 1. Again, I'm using these points from the rectangular coordinate. This simplifies to tangent equals negative square root of 3. So again, the question here is, where in unit circle is this true? Okay, now you have to think about where in the unit circle is tangent negative. Well, tangent's going to be negative in quadrant 2 or in quadrant 4. All right, so think about your reference angle. We talked earlier, I told you that it would be helpful to memorize where these would fall. So if I look here, this is what I'm looking for. I'm looking for the square root of 3, and I'm looking for a pi over 3 reference angle, if you want to think of it that way. So tangent needs to be negative, so I know it's going to be in quadrant 2 or 4. This is why it helps me to plot it first, because I want it to be in quadrant 2, and it makes sense that it's negative there. And then knowing that it's going to be a pi over 3 reference angle, this puts me at 2 pi over 3. Okay, so that is going to be my theta, which means this is my answer. That's how I convert it over. So again, it helps you to know that tangent is going to be some form of square root of 3 at any pi over 3. So I know that this is pi over 3 here. This is 2 pi over 3. And so tangent is going to be negative here. That's why I'm using it. All right, let's go ahead and do a few more. So 2 comma negative 2. Again, it helps to graph that. How would you graph the point 2, negative 2? You would be down here somewhere, right? This is 2, this is negative 2. So we want to make sure that our answer is in quadrant 4. And let's just see where that gets us. So first, solving for r. Again, this is your x, this is your y. We're going from rectangular coordinates to polar coordinates. So to solve for r, we're going to do square root of x squared plus y squared. In this case, that is 2 squared plus negative 2 squared, which reduces to square root of 8. And we are asking you to simplify that if possible, which reduces to 2 square root of 2. Okay, now to find, so that's your r. That's going to be my first number here. To find my theta, I'm going to use tangent y over x. In this case, my y is negative 2. My x is positive 2. So I'm looking for where in the unit circle would tangent have a negative 1. Okay, so again, thinking about how tangent is negative at either quadrant 2 or quadrant 4, and it helps to graph, so I know I need to be in quadrant 4. Thinking about my values of tangent, where tangent is going to have a pi or a negative 1, that's going to be a pi over 4 reference. And how would I write this if I went down to pi over 4 or all the way around, however you want to think of it? But this is going to be your pi over 4 reference angle. And so hopefully, now that you know your unit circle, this is going to be at 7 pi over 4. So that is your theta. All right, just 2 more examples here. So again, let's start off by graphing this. We're going left 2 and then just at 0. To find my r value, square root of x squared plus y squared. So in this case, that's negative 2 squared plus 0 squared, which is square root of 4, which is 2. So r is 2. And then to find my theta, I'm going to use tangent y over x, 0 over negative 2, which is 0. So where in unit circle does this happen? Where is tangent going to be 0? Okay. Well, it helps that I graphed it first, and it makes sense. How would I label that point, right? This is going to be at pi, and that is just how you find your angle, your theta. Thinking about that point in the unit circle, that would be a -1 or -1, 0, which is a tangent of 0. 0 divided by anything is just going to be 0. Okay, so that one's pretty easy. Last one, I'll start off by graphing. Again, -1/4 is going to be left, negative square root of 3 is going to be down. So I'm in my third quadrant once I figure out what my theta is going to be. My r is found by squaring the x value, adding it to the y value also being squared. You can use a calculator for these, or you can also do them by hand. This is 1/16 plus 3/16, which becomes 4/16. And if you split this up into square root of 4 over square root of 16, your r will simplify to 2/4 or 1/2. So my r value will be 1/2 for this one. And then finding my theta, I'm going to use tangent. And that's my y value over my x value. And in this case, you are going to skip, flip, multiply. So we're dividing fractions. So I'm going to skip this one, and I'm going to flip the other one. And then I'm going to multiply. So when I do this, the negatives will cancel. The 4's will cancel too, actually. And then I'm just left with a positive square root of 3, which makes sense. Now, you just need to know where in the unit circle this is going to happen. The positive tangent happens in quadrant 1 and quadrant 3, which is where I want my theta to be, so that's good. And then think about which reference angle equals square root of 3, okay? And that's going to be the pi/3 reference angle, but in quadrant 3 this time. So you need to think about, okay, what does that make this one? And that makes this 4 pi/3. Right, because this would be right here, normal square root of 3. This right here would be 2 pi over 3. I don't know why I said square root of 3. And then one more here, this reference angle in quadrant 3 is 4 pi over 3. So this is my angle theta, and that's how I take that rectangular coordinate into a polar coordinate. And that's the end of our notes.